Hi, my name is Aravin Sivakumar, student number 400064445, and I'm going to be demoing my 2DP4 project today. So here's a generic code and the actual setup. So we have ADC5 and ADC4, which were used for X and Y respectively, a resolution of 10-bit and a bus speed of 6 megahertz. The bus speed of 6 megahertz is used to find the baud rate, which is 9600. So we used that because we wanted a plus or minus error of plus or minus 6%. And we used a baud divisor 39. So what I'm going to do is I'm going to go over the code through the actual debugger very quickly. So you can actually see my code, and then we can see the different modes being used. So firstly, so we enter the while loop. If I press 1, then we know that we should jump to the next interrupt function, which we do, and this initializes serial communication. So that's good to go. And then if we press the second mode button, this should initialize the second axis flip to the y-axis, which we're doing here. So that's perfect. And then, so what I'm going to do right now is just flip back the serial communication. So as you can see, we used a pure interrupt structure. So this is for the first bonus, and that is good to go. So now what we're going to do now is I'm going to just run through this code. Serial communication is currently disabled, and I'm going to begin my MATLAB code. And then I'm going to just hold the accelerometer at the ideal place. And then I'm going to begin the code. And perfect. And that's done. I'm going to just stop the serial communication. And so the MATLAB plot has been plotted right here. There is a little bit of noise near the end, but that's just me putting the thing down. Here is the actual angles where I was actually holding it properly. And as you can see here, we're well within the range of desired 0 to 90. As I mentioned before, the overshoots were because of some noise in my accelerometer and so just potential error initially. So, and whenever you go beyond the 90 degrees, you go well over the overshoot, and that doesn't work in the linearization formula. So that's why you can see those values coming up. But again, as I mentioned before, these are the correct values that I was actually adjusting the angle accordingly. Now what I'm going to do is I'm going to do the same, but now for the x-axis. So now in order to do that, I'm just going to reset all my code. This has been reset. I'm going to reset this now. Now that this is reset, so now I'm going to step over all my code. I'm going to begin the communication on the MATLAB. And now I'm going to just begin this here and show you the corresponding plots again. So give me a second to pull up the MATLAB. So as you can see, we had some noise initially but we also have the correct angles on majority of them. So as you can see here, we're mostly plus or minus 90, some potential overshoot just above 100 here. Again, some little errors in the linearization formula. But again, I found those to be quite negligible. So for the most part, the real-time graphing works just fine. If you want to see it in real time, what I can actually do is just increase the duration of this while loop. I can reset my MATLAB code just in case there's any speculation about how it's being graphed. I can reset this, step over the whole thing, begin running this, and start running this. And as you can see, it's being plotted in real time. So everything plots in real time. Again, some noise here and there, but for the most part stays within 90, which is exactly what we want as I'm adjusting the angle, as you can see there. So that all works fine. I'm just going to quickly do a quick walkthrough of my code. So again, as you can see here, this is just the LEDs. I just wanted to display for you. So as you can see for the X particularly, as we approach a value of 0, the most significant LEDs begin to blank out. And as we approach a value of 90, the most significant LEDs are very prominent, which means that we are approaching a much higher value. And we can see the same effect if we were to flip the y-axis. If we were to flip to the y-axis, and the same effect can be seen. So the LEDs work fine. This is angling in real time. And again, the corresponding graphs with some noise. Again, so just as a quick run through, I can actually run you through all my code just very quickly. So as we step through, we have initialization, the main function, 9600, as I mentioned before. and the serial communication, all these parameters being set up. So I'm just gonna step through this very quickly because I know I'm over time. And then I'm just going to show you that as I press the first button, we initialize the first interrupt, which is exactly what we want, the serial communication enabler. The second button is pressed, the second button gets jumped to the access flipper, which is perfect. And then we do the corresponding calculations, which are all done here. We calculate the value based on the formula. We calculate sine inverses. There's no trigonometric capabilities within the C. We use a Taylor series, and that is it. So that's my entire project with the first bonus being complete. And yeah, thanks for watching.